Alright, so in this video we'll be talking about the Lewis dot structure, how to draw the Lewis dot structure. Alright, so now before we dive into Lewis dot structure, we have to understand some key concepts. Right. So the first thing we need to understand is what we call valence electrons. Right, valence electrons. So valence electrons are the electrons that are found in the outermost shell of an element. Yes, they are found in the outermost shell of an element. Okay, let's take for example carbon. Let's take carbon for example with symbol C. Okay, carbon has an atomic mass of 6, right? 6. So writing it, that would be 2,4, right? So let's draw the shell of carbon. So we have something like this. We have 2, right? Then 4, we have 1, 2, 3, 4. So this is the outermost shell. This, right? So the number of electrons in the outermost shell is how many? 1, 2, 3, 4. So the valence electron of what carbon is what? Is 4. Let's take another example. Let's say chlorine, for example. Chlorine. So chlorine has an atomic number of 17. That's 287, right? So drawing the shell of chlorine, we have something like this. 2. And for this, we have 1, 2, 3, 4, 5, 6, 7, 8. We have what? 7, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this is the valence shell, right? That's the outermost shell. So how many electrons are in the outermost shell? We have 1, 2, 3, 4, 5, 6, 7. So the valence electron of chlorine is actually 7. So you need to understand what the valence electron is. Alright, so there's something we call the octet rule. The octet rule. So the octet rule is just the ability of an atom to have a stable electronic configuration. That is to have 8 electrons in the valence shell. Alright. So now let's take an example for chlorine. It has 7 electrons in its valence shell, right? For you to have an octet structure, there must be a transfer of electron from another atom when it wants to undergo chemical bonding. Then when there's a transfer of 1 electron from another atom, then it will have an octet structure. Do you get that? So that's what the octet rule is all about. Alright, so we have the Lewis symbol or the Lewis structure. Alright, so the Lewis symbol basically we denote lone pair of electrons with a dot. So these are the dots. It's dots. So we denote lone pair of electrons with dots, right? Or the valence electron are denoted with dots, right? While we denote the bonds, covalent bonds, with what? With a line. So this is a single covalent bond, this is a double covalent bond, and this is a triple covalent bond. So you get, so electrons, valence electrons are denoted with what? With dots, while bonds, covalent bonds are denoted with what? With lines. And let's note something. 2 lone pairs of electrons will form a covalent bond. So if I have 2 lone pairs of electrons, they can combine together to form what? 1 covalent bond. So if I have 4, let's say I have 4 lone pairs of electrons, they can combine to form 2. Same thing if I have 6 lone pairs of electrons, 1, 2, 3, 4, 5, 6, they can combine to what? To form 3 covalent bonds. Triple covalent bonds. Do you get that? So that's the basics of drawing Lewis structure. So now we'll be going into examples of atoms and molecules. How to draw their So the first example is let's start with carbon. Alright, so this is how we do it. So what is the what do you call it? What is the atomic number of carbon? Atomic number of carbon is what? Is 6, right? So writing it, so it will be 2, 4, right? So it means carbon has what? 4 valence electrons. So this is how we draw the Lewis structure of carbon. You write carbon with its symbol C. Then 4 valence electron. I told you valence electron are denoted with what? With dots. So carbon will have 4 dots. 1, 2, 3, 4. And this is the Lewis structure of what? Of carbon. Do you get that? It will have what? 4 dots. Because of it has what? 4 valence electron. Let's take for example oxygen. So atomic number of oxygen is 8. That's 2, 6, right? So this is how you write the Lewis structure of oxygen. So which means oxygen has 6 valence electrons, right? 6. So you have O for oxygen, then 6 valence electron. 1, 2, 3, 4, 5, 6. The dots position does not really matter. Just make sure it is what? It's 6 dots. 1, 2, 3, 4, 5, 6. Alright. So you can try for other examples, other elements to just the number of valence electrons, just put it around the element. That's it. Alright, so let's go to let's take some ions and work with them. So let's say we have S2 minus, the sulfur ion. Alright, so this sulfur ion. Alright, so now the atomic number of sulfur basically is what? Is 16. So 286. So it's meant to have 6 valence electrons, but it is carrying a charge, right? 2 minus. It's carrying a charge, right? So the total number of electron of this ion will now be its what do you call it? Its atomic number plus, since it's negative charge, means it is what? Gaining electron. That's plus 2. It means the total number of electron there will be 18, not 16. So when you have an ion like that, if it is negatively charged, you add the ion to the atomic number to get the total number of electron. Then you can now do it like this. So it will be 288, right, for 18. So the Lewis structure of sulfur ion will now be something like this. Yes, don't forget your 2. So it's 1, 2, 3, 4, 5, 6, 7, 8. Then don't forget your what? Your charge. Right? If it were to be ordinary sulfur, it will be 6 dots that will be there. But because it is carrying a charge, you find the what? The total number of what? Electrons. Then you don't forget to put the charge outside. Right? So let's take the last example for ions. That's the, let's say, K+, potassium. Right? So normally the right, so for K+, it has 19 electrons, right? That's the atomic number 19. That's 2881, right? But it is carrying a charge, a positive charge. So I told you, when you have a negative charge, what you add. But when you have a positive charge, it means it has lost 1 electron. So you minus 1 from this, which means the valence electron here is what? 0, right? So to write the Lewis structure of K+, it will not have any dots. Not the K plus. You get that? Right, so let's move on to some so for E, let's say we are dealing with hydrochloric acid, HCl. So now this is how we write Lewis structure for HCl. So you have your H here and then HCl, right? So it's just the same concept. Each hydrogen has how many valence electrons? It's 1. Right? So if you have what 1 dot, right? Chlorine, that's 17, that's 2, 8, 7, right? So it has how many valence electrons? 7, right? So have the 7, 1, 2, 3, 4, 5, 6, 7. Now it's time for them to bond. And I told you that 2 lone pair will form what? A covalent bond, right? So the lone pair nitrogen can bond with that of covalent to form a covalent bond. So can we see that? So the Lewis structure for this cell cannot be written like this. H, then we have a covalent bond, Cl. H will not have any dot again because it has combined with that of covalent. So this instead of 7, so it will become 6. So if you have 1, 2, 3, 4, 5, 6, and this is Lewis structure for HCl. Hope you get that. Don't mind my dots. You get that. This is Lewis structure for HCl. Alright, so let's take another example. That will be F. Another example F. Let's say CO2. Right, so CO2. That's 2 oxygens and 2 carbons. So we have O, C, O. That's CO2, right? So carbon has 4 valence electrons, so it will be 1, 2, 3, 4. I've taught us how to do this. Oxygen has 6, so it's going to be 6 plus 1, 2, 3, 4, then maybe 5, 6. Then here 2, oxygen 6, 1, 2, 3, 4, 5, and maybe 6. Right. So now let's start bonding. So one valence one lone pair can pair with this to form a covalent bond. 1 here 2. Alright, so carbon still have what do you call it? Lone pair of valence electron. So they can also combine with another one and another one here to combine. So carbon now is stable, so it does not have any pair again. So the Lewis structure of CO2 cannot be written like this. Don't forget that we have made 2 covalent bonds now. So it's not have this. So that's why if you see the structure of CO2, you see covalent, you see double bonds there. You see double bonds. So the double bonds. So carbon will not have any dot again because all the dots has combined with the electrons. What the lone pair of electrons combined with that of oxygen. So instead of oxygen to have 4, instead of it to have 6 dots, it's going to have 4 now, right? Because of the other 2 have combined with that of carbon. So we have 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. So this is the Lewis structure for CO2. Right, so we have 3 more examples to try out. So we have H2S, HCN, and BF3. Right, so now let's start. H2S. So the same thing applies. Sulfur, hydrogen. So hydrogen has 1, right? So hydrogen 1, 1, right? Sulfur is what? Sulfur is 16. That's 2,8,6. So that's 6 for valence electron, right? So it will be 1, 2, 3, 4, 5, 6, right? So these can combine with this to form a covalent bond. These can also combine with this to form a covalent bond. So the Lewis structure for H2S will be something like this: a covalent bond. Hydrogen will have no bond again. 1, 2, 3, 4. So this is Lewis structure for H2S. You get that now? That is very, very easy to do. For H, we have the HCN. Here we have 3 elements. So we have H, that's hydrogen. We have carbon. We have what? Nitrogen. So H is always 1. That's 1. So 1 dot. Carbon has what? 4. 1, 2, 3, 4. Nitrogen is has 7. The atomic number for nitrogen is 7. That's 2,5. So the valence electron will be 5. So we can have 1, 2, a lone pair for hydrogen can combine with that of carbon to form one covalent bond, right? So we have 3 left. So we can have 3. These 3 other lone pairs of carbon can combine with 3 from nitrogen, right? So we can have something like this. They form 1, 2, 3. So they form a triple covalent bond. Remaining these 2 lone pair of electron. So the Lewis structure for HCN can be written like this: H, a single bond, C, then a triple bond, right? Then N. Don't forget your 2 dots. Lone pair of electron that's not combined. This is Lewis structure. So our last example for this video is BF3, carbon fluoride. So this is B. This bond is the central atom with 3 fluorine atoms. 1, 2, 3. Right. So boron has atomic number of 5, right? So that's 2, 3. So boron will have 3 dots. So we have 1, 2, 3. Right? Fluorine is 9. It has 7. 2,7. So that's 7 valence electron. Yeah, it's an halogen. So we have 1, 2, 3, 4, 5, 6, 7. Fluorine again. 1, 2, 3, 4, 5, 6, 7. Fluorine again. 1, 2, 3, 4, 5, 6, 7. Alright, so since boron just have 3 lone pair of electrons, so they can combine to form covalent bond, and what's covalent bond. So the Lewis structure for BF3 can now be like this. Don't forget this boron, a covalent bond, fluorine covalent bond, and a covalent bond. And don't forget the other dots. No, it was 7. Only 1 combined, so it will remain 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so this is how to draw Lewis structure of molecules. So you can see they're not really that difficult to do. Just understand the concept of valence electron, the octet rule, and don't forget that lone pair of electron are denoted with dots, while bonds, covalent bonds are denoted with line. So double covalent bond, single line. Sorry, single covalent bond, single line. Double 2 lines, 3 lines. And don't forget, when you have ions, anions you add, while cations what you subtract. Hope you get the concept. So thanks so much for watching the video. Thank you so much.